In this video, we are going to name two types of acids, which are considered as molecular compounds, and these two acids are binary acids and oxyacids. So starting with what is an acid in general, as I mentioned, an acid is a type of molecular compound that contains one or more hydrogens in addition to an atom or atoms. And when dissolved in water, they produce hydrogen ions. And there are two types of inorganic acids. And I mentioned that these are inorganic acids because we have mentioned in another video that there are organic acids and they follow their own nomenclatures. So the two types we are going to discuss are binary and oxyacids. So starting with a binary acid. So from the name binary means that you can have hydrogen or hydrogens in addition to a nonmetal. So for example, something like HCl or HF. And when it comes to oxyacids, similar to oxyanion, so they contain oxygen in them, okay? And in this case, oxyacids will consist of hydrogen or hydrogens in addition to an oxyanion. So examples are H3PO4 or HNO3. Now, let's start by naming binary acids. So naming binary acids is going to be very simple. We're going to start with the prefix hydro, and then we are going to, following is going to be the base name of the metal, okay, plus the suffix IC or ic, and then the word acid. So let's look how we're going to name this. So for example, we have the first one. The first example here is hydro, indicates that there's a hydrogen. And then we have here chlor, which is for chlorine, and then IC, so hydrochloric acid. Okay. The second example, HF, same thing. We will add hydro and then fluor, and then IC, hydrofluoric acid. The last one is going to be, try to pause the video and work on this on your own, is going to be hydrocyanic acid. Very simple. Now, I want to remind you that the states of matter, when it comes to naming these compounds or naming binary acids, becomes very important. If you note on this slide, the state of matter here is aqueous. So if you see that it is aqueous right here, you will follow the conventional naming for binary acids. If you have a gas instead of an aqueous state of matter, in this case, you will follow the conventional naming for molecular compounds. So I'm going to remind you again. So HF, for example, is going to be hydrogen fluoride. HCl is hydrogen chloride. Something like H2S is going to be hydrogen sulfide is acceptable, or dihydrogen monosulfide. Now let's start by naming now, or shifting gears to naming oxyacid. So oxyacid is going to be a little different because we are going to name the oxyacid or derive the name based on the oxyanion. So how do we know, or how we differentiate the different types of oxyacids based on the oxyanion, or specifically some oxyacids end in IC or OUS suffixes. So in this case, again, if the oxyanion ends in ATE, so remember ATE used to indicate that there are more oxygens, we drop the ATE and then we convert it to IC in the root of the name. So here is the rule. is going to be the base of the oxyanion. Okay, so for example, let's take this example. So we have here nitrate is my oxyanion. So instead of nitrate, we will drop the ATE at the end and we'll convert it to an IC, so it becomes nitric. And then we will add the word acid, so nitric acid. Okay, now if an oxyanion ends with ITE, so remember ITE used to indicate the lower number of oxygens in the oxyanion, we will drop the ITE in the end and then we will convert it to OUS. And just for your reference, on the next slide right here, I put all the common oxyanions and their corresponding acids to them. So let's look at the example right here. So we're going to, similar to what I did with nitric acid, right here, I'm going to start with the base name of the oxyanion and then drop the ITE and add OUS and then the word acid. So we have here, this ion is here is chloride ion. And instead of chloride, I will drop it and then convert it to OUS. So it becomes chlorous acid. Okay. Now, I want you to pause your video and try your best to name all these oxyacids based on the naming convention that I just explained. And while you're doing that, I'm going to work through each example. So starting with A, so we have here, this ion is phosphate. Okay, and since phosphate has so many oxygens, I'm going to drop this and convert it to IC, so it becomes phosphoric acid. Okay, now the second example right here is ClO4. Now, do we remember what is ClO4? Yes, it is the perchlorate ion. Okay, so we will drop the ATE and do perchloric acid. Very good. Now, for C, yes, you guessed it. This is sulfite. Okay, instead of sulfite, we were going to drop the ITE and becomes sulfurous acid. Very good. Choice D, we have here now more oxygens in SO4 than SO3. So it's sulfate, okay? And instead, drop it and becomes sulfuric acid, okay? Now, the last one right here is the hypobromite ion. So remember, hypo means lacking, least number of oxygens, so becomes here hypobromite. Okay, and instead we're going to drop the ITE and becomes hypobromous acid.